We are going to continue to talk about exponential functions. We're going to deal with some real world word problems. So this is where it's actually used. So there's a lot of application with growth and decay, dealing with interest, dealing with items increasing in value or decreasing in value. You've seen some of this before, probably in seventh grade. So it's been a while. So we are going to start with exponential growth. So here on the left side, f of x equals a 1 plus r raised to the t. R, let's go ahead and write that. R is going to be your rate slash percent. Go ahead and write that down. So let's say your bank account gives you 10% interest, which is unheard of. Or you have a credit card and they charge you 24% interest. So these are some real world applications. So student loans, that's an example, 8% interest. So it's compounded and it continues to increase your balance because of that interest. Percent, as a review, percent means out of 100. So I'm going to put the percent sign over 100. And we are going to convert that to a decimal. The easiest way to do it is using our calculator. What we are going to do is we are going to put the percent out of 100, and then we are going to write as a decimal. If you remember that you can move your decimal over 2 places to change it to a decimal, you can do that. But it's just easy to put in your calculator, come up with that value. So you'll use percent and rate on both of these problems. I just wanted to remind y'all about those things before we went to the inside. Okay, so growth, remember the b value? Let's go ahead and write that f of x equals a times b raised to the x. A was the initial amount, b is the percent or the increase, decrease, growth or decay. I think it was called growth or decay factor. So for growth, it says 1 plus r. So that means it's going to be larger than 1. For decay, it says 1 minus r. So it's going to be smaller than 1. That's how we know it's decay. Okay, let's go ahead and open this up. So with growth, it looks like this. It increases rapidly. Decay, it decreases rapidly. Remember, we read it from left to right. So that's why I just left the arrows on this side. All right, so for exponential growth, we have this a times 1 plus r to the t. So a is your initial amount or balance. We're going to write out what each of these letters means. R is your rate, and T is time. Wherever you did this in seventh grade, we did simple interest was just P times R times T. But growth, like this exponential growth, is more of a compound interest type thing. So it has the exponential or the value as your exponent. Okay, so we're going to look at a couple of examples. Example 1, the exponential function below models the amount of money in Jose's savings account where x represents the number of years since he invested the money. So what does 3,000 represent? So if we look at our function, A is the initial amount. So right here is your initial amount. So that's your A. or we could write it as starting a balance. So Jose started his account with $3,000, starting balance or initial amount. And then our growth rate, we have to find out what this is. So it's 1 plus R to the T. That's a T. Okay. So we need to know what the growth rate is. So it says 1.06 is the 1 plus R. So 1 plus R is going to give us 1.06. So in order to find the rate, we could just subtract those. We could take 1.06 and subtract it from 1. 1.06 minus 1, what does that equal? Yeah, just 0.06. So that is our rate, but let's find it as a percent. How do I change from a decimal to a percent? Percent. If it was already percent, so we're actually going to multiply it times 100. So we, instead of dividing, we would multiply it because we're going the opposite way. So that would be 6%. Or you'd move it over 2 places. So 6%. Pretty good percentage amount. Usually bank accounts are like 0.0005%. It's like nothing almost. If you look at your bank statement, if you ever have time to look at, if you have a savings account anyway, if you look at your bank statement, how much interest you earn, it's very little. If you have like $500 in there, it's like a couple of cents a year. It's not much, but it's something. All right. So the example two, the cost of tuition at a state college is 8,500 and is increasing by 3% each year. What is the cost of tuition after 6 years? So we're going to underline the important information. So we need to know the initial amount, 8,500. So go ahead and put A there, and I'm going to circle it, 8,500. It's increasing. Underline the word increasing. So we know it's going to be growth and not decay at a rate. So R is 3%. Go ahead and label that with R and circle it. So it says, what is the cost after 6 years? So F of X equals, we're going to write our equation before we find out how much it's going to be for 6 years. So A times 1 plus R raised to the T. So it's going to be 8,500. And since it's increasing, I'm going to do 1 plus, but I'm not going to do 3. I need that as a decimal. So this would be 3 out of 100 because it's percent per 100. 3 out of 100. Oh, 0.03 is our rate. 1 plus 0.03 raised to the x. So we're going to simplify it. So go ahead and put f of x equals 8,500. 1 plus 0.03. 1.03 raised to the x. So that's our function. So it's 1.03. 3% is the increase, so it's more than what it was. 1 would just keep it the same, but anything above 1 is going to make it an increase. We're going to put this in, and it's asking, what is the cost after 6 years? So after 6 years, the cost is, we got to find what the cost is. What do we have to do to find for 6 years? That's an exponent. So you're going to substitute it in. You're going to raise it to the 6 instead of multiplying. So it'd be 8,500 parentheses 1.03. Everybody do this. Raised to the 6. It's exponential growth, so your 6 has to be your exponent. Okay, so this is what it comes out to be. So it's dealing with money. So we're going to round to 2 decimal places. 10,149.44. 10,149.44. So after 6 years, that's the new cost. So it was 8,500. Now it's 10,149.44 cents. So it's gone up. All right, let's look at example 3. I want you to read it to yourself. Identify the A and the rate. Go ahead and highlight, underline. Don't forget to do the 4.7 out of 100 to change it to a decimal. It's a decimal that, or a percent that's written as a decimal, but you still have to convert it to a decimal because you're not going to put percent into the equation. Go ahead and write your equation now that we have all of the information we need. So I'm going to go ahead and read it. Sally deposits $10,000 into an account that pays 4.7% interest compounded yearly. What's the balance after 5 years? So she deposits 10,000, so that's her starting balance or her initial amount. It's paying, so that's an increase on her account by 4.7%. Percent means out of 100, so I'm going to go ahead and divide that. 4.7 divided by 100 gives me 0.047. So whenever I plug it into that equation, remember the equation is 1 plus R, so it's 10,000. 1 plus the rate, 0.047, raised to, and we'll go ahead and simplify it. Or you just add by 1, you're just going to basically tack on that 1 to the decimal. See, that's just 1.047 now, raised to the x. And we want to find what's the balance after 5 years. So I'm going to go ahead and start my sentence. After 5 years, balance is, we're going to plug in 5 for that. So 10,000, 1.047 raised to the 5. And this is money again, so we're going to go two decimal places. 12,581 point. We're going two decimal places. That'd be $53. $53. So it's increased. So just make sure at the end whenever you read it that that makes sense. If she's depositing and it's earning interest, it's going to be more than it was. Pretty good deal. 5 years, she made $2,581. Pretty good. Just by putting her money in that account. All right, so let's do decay now. So decay means it's getting smaller. It's a decrease. We have a very similar equation. The difference is growth means you're adding, decay means you're subtracting. So A is the same thing, initial amount. R is your rate, and T is time. So this time, in order to find the rate, you're going to have to subtract from 1. Instead of adding 1, you're going to subtract 1 from 1. Let's look at example 4. Exponential function below models the value of Melissa's car, where x represents the number of years since she purchased the car. F of x equals 28,000 times 0.86 raised to the x. So what's happening to the value of her car? It's a decrease. Yeah. So decrease. As soon as you drive the car off the lot, whenever you buy it, the value decreases just right away because it's no longer a new car. If it's a used car, you're no longer the second owner. I mean, you're the second owner, but the next person would be the third owner. So that makes it go down in value. Still good. All right. So what does the 28,000 represent? That's like your A. A is the initial amount. But in this situation, she's buying a car. So what does 28,000 represent? Yeah, cost. Purchase price, or it could be the value, current value. Also, I'll explain in a second. So in this situation, yeah, it is the initial amount, but we're talking about this actual situation. She bought a car, right? So 28,000, how much she bought the car for, or the car's value. The decay, we got to look at this. It's 1 minus R raised to the T. 1 minus R raised to the T. So 86 is the outcome. So it's 1 minus R 0.86. So look at these two. Says the rate is 1 plus already at 1.06. Now it's decay, so it's 1 minus R. So the easiest way to find out how much the rate is just subtract. Do 1 minus 0.86. 1 minus 0.86. 0.14. So that's your rate of decrease. That's how much it goes down by. So rate is 0.14. The rate is not 0.86. That's your decay factor. To find your rate, you would take it away from 1. And then to find your percent, just move it over 2 places. Give you 14%. It's a decrease also. So 14% decrease, which is crazy. Yeah, it went down a lot. So the value of the car is going down really fast at 14%. Okay, so let's look at the example. Student population of local high school is 1,375 and is decreasing by 2% each year. What will the student population be after 7 years? So let's start with identifying A, the initial population. Go ahead and write A to the side, circle it. It's decreasing, so underline the word decreasing by a rate of 2% each year. So that's your rate. Circle rate. So you're going to have to pay attention to how we're going to use this in our equation. Because when we add it, it just kind of makes sense. But subtracting it, it's a little bit more confusing. So pay attention. Here is our equation. So if it's decreasing, we're going to do 1 minus the rate. The rate is 2%. But we need to put it out of 100 because we want it as a decimal. So do 2 out of 100 equals 0.02. Since we have that keyword decreasing, we're going to do the 1 minus 0.02, not adding. So our equation is like this. Look back up here. A is first, so it's 1,375. Go ahead and put that down. That's your A. And then do 1 minus the rate, because that's what it says. 1 minus the rate. Let me finish this problem first. 0.02. And then it's raised to the x. We do need to simplify this. So let's go ahead and do 1 minus 0.02 and rewrite. 1,375. When we did 1 minus 0.02, it's right here in my calculator, 0.98 raised to the x. So that's the equation. Remember, decay means it's decreasing at some kind of factor. So we don't use our rate. We have to either add or subtract by 1. Since it's decreasing, we're subtracting by 1. So that's why it says 1 minus. Now it says, what will the student population be after 7 years? So after 7 years, the pop is, we're going to plug in 7 for x. We're going to put that in the calculator. Find out what it equals. And this is dealing with number of people, so I would round to the nearest whole number. 1,194. Now you'll look at the next one.